Okay, this is screencast CO5 question 2, and the question states, suppose you are climbing a rope that is hanging freely from the ceiling of a gym. The rope does not stretch as you climb it. If you climb to a height h, how much work has been done on you by gravity, and how much work has been done on you by the rope? So I started off here drawing a picture of a person hanging from a rope, and then I drew the height, which the bottom is the initial height and the top is the final, since you're climbing upwards. Then my coordinate system, up is positive y and to the right is positive x. So then I drew a free body diagram. So the force of tension is upwards, and then the force of gravity, which is mg, is then downwards. So for part 1, it says how much work has been done on you by gravity. So work equals force times distance, and since we're finding how much work has been done on you by gravity, the force is gravity in this situation. We're using the force of gravity. So work equals force of gravity, which is mg, times distance, which is our height. And then next step, we have work equals negative mgh, since my coordinate system up here states up is positive y, and since gravity is working downwards, that's going to be the negative direction. So we're going to have negative mgh. And the only value we know to plug into this is 9.8. So our answer is work equals negative m times 9.8 times h. And the negative is again because of the negative direction. And then part 2 says how much work has been done on you by the rope. So work equals force of rope, which is the force tension, times distance. So work equals force tension, which distance again is height. So then if we do the sum of the forces from our free body diagram, the sum of the forces in the y direction equals may, and there's no acceleration, so it's 0. So then we know force of tension minus mg equals 0. If you solve for that, the force of tension equals mg. So we can plug that mg in for force of tension now. So if we go back over here, work now equals mg times h. And again, the only value we know to plug in is gravity, which is 9.8. So now for part 2, we're left with work equals positive m times 9.8 times h. So for part 1 is negative, part 2 is positive, but this all depends on our coordinate system. So if my coordinate system would have been flipped a different way, our answers would have been different. But these are our answers due to the coordinate system.